Symbols of our industrial civilization: power, transport, a labour force. And also materials present at the birth of civilization: metals. Man had to master mass production and metal processing in order to develop the many spheres of activity that make up our life today. Even at the beginning of the 21st century, we still use the key basic material, metal. Numerous products are currently made of metal. Firstly, metal is necessary for making machines and tools, or their most important parts. Compared with the latest non-metallic materials, metals feature some unique properties that justify their use in industrial production. Comtess is a young and rapidly growing company that carries out applied research and development in metallurgy and provides its results to manufacturing firms. Its activities are focused mainly on metal forming, heat treatment, and materials engineering. In line with current global trends, the company focuses on technologies for manufacturing top-quality products, requiring only very simple post-processing. Company specialists build upon traditions and experience in the manufacturing of highly complex products, such as large crankshafts for marine engines. A new forming procedure has been developed for these sizable forgings.
We've developed a new technology to improve the resulting shape of a forged shaft, as well as its properties.
We've also cut costs for its reprocessing. Comtess experts develop procedures that are based on current needs to cut production costs, save material, energy and labour. That's why they design technologies for production at lowered temperatures, requiring the shortest possible production time. The technological process for manufacturing each product is designed as a whole. It must therefore include the design of optimum tools. Forming tools must withstand ever-increasing thermal and mechanical stresses. Numerical modelling methods are used by Comtess to design these tools. This is illustrated by tool loading over the course of the forming process. The production of tools requires a special high-strength metallic and ceramic materials, as well as composites. Their treatment is often very complicated, involving the use of the latest methods in metal cutting and surface treatment. The Comtess Research and Development team is also working on extending the durability of tools. Selecting the optimum materials, the shape of tools and their surface treatment is of key importance. This results in not only higher durability of tools, but also high precision of the products being formed. Forming technology is used to make products of various sizes and weight, from millimeters to meters, from several grams to hundreds of tons. Comtess has designed technological processes for forming a number of products made of metals and non-metallic materials, including plastics and glass. Comtess experts cooperate with a number of research and development institutes both at home and abroad. Its closest partner is the University of West Bohemia in Pilsen. University laboratories are frequently utilized to verify material treatment technologies designed by Comtess. Small specimens are used to simulate forming conditions in the most important parts of a full-size product. This is followed by the production of scale models or prototypes. In this way, we can determine suitable parameters for actual production. The automotive and aerospace industries provide most incentives for research and development of new materials and for innovations in the treatment of currently used materials. Ever-increasing market competition forces even the largest manufacturers to cut production costs. This would not be possible without up-to-date, powerful and efficient technological processes. While looking for optimal materials for forming tools and actual products, COMTES experts utilize global literature surveys of current research and development. The final decision on the best solution is always a combination of numerical modeling, laboratory experiments and verification tests in production plants. Material samples are subjected to a detailed metallographic analysis. Polished sections are used to reveal the details of the metal's inner structure. Each sample, in the form of a model, provides important information on the material's properties, which is essential to ensure the quality of the final product or semi-product. This will either confirm or disprove predictions based on numerical modeling. By using a microscope and making a series of additional tests, we can find out whether we've achieved all the required material properties, such as strength, hardness, toughness, thermal conductivity, expansion, flow stress, and durability under dynamic loading. The structure of material being formed contains flow lines that copy material flow during forming. Disturbances of these flow lines may impair mechanical properties and durability. That's why COMTES has come up with an important innovation. The current technological process ensures that disturbance of these flow lines is limited in subsequent machining. This means that these flow lines must be made by forming into the resulting shape of a particular crankshaft. COMTES researchers, together with Škoda Holding of Pilsen, were the first in the world to propose a new open-die forging method for these sizable forgings. The forging procedure was tested by means of a scale model on a scale of 1 to 5. In June 2001, the first forging of a crankshaft with a total weight of 25 tons took place in the forging plant of Škoda Holding using the newly proposed technology. This new technology not only minimizes impairment of shaft properties during subsequent machining, but also cuts post-processing costs for these forgings. COMTES is engaged in basic and applied research in the fields of metallurgy and materials engineering. The company participates in a number of research projects, both in the Czech Republic and in cooperation with its foreign partners. International projects are supported by our own authorities, the Czech Ministry of Education, which is in charge of science, as well as by the EU, through projects supported directly from Brussels. Research projects conducted by COMTES specialists involve the development of finely structured materials and low-temperature forming processes aimed at cutting energy consumption. Other areas of research include technology for components of a new type of nuclear reactor and the development of nanomaterials, a new worldwide trend. COMTES, a company that guarantees state-of-the-art metallurgical technology.